Hi, this is Randall Schwartz, host of Floss Weekly. This week, Aaron Newcomb joins me. We're going to be talking about faster Perl, as in RPerl. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Randall Schwartz and Aaron Newcomb, episode 384 for April 19th, 2016, RPerl. This episode of Floss Weekly is brought to you by Braintree. Mobile app development can be complex, but integrating your payments no longer has to be. With Braintree, your business can accept nearly every type of payment from any device with just one integration. Learn more at braintreepayments.com/floss. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS in the billing section to get your $10 credit. It's time for Floss Weekly, the show about free, libre, open source software. I'm your host, Randall Schwartz, Merlin at StoneHenge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day and unaware of it, projects you may find out about today and want to go download it and play with it right away. Joining me today is Aaron Newcomb. Welcome back to the show.
Hey, thanks, Randall. Good to be here.
And what is that background? It's not your devious lair.
It's not my the lair of makery goodness. It's actually the brick house. Yeah.
Made it all the way up Petaluma today, huh?
Yeah, I haven't been here in a while. Ever since we changed the show time to 8:30, and then I got used to doing it at home, and then it worked out better for my work schedule. But today I actually have to go up later on to Roanoke Park to meet with Congressman Mike Thompson. They're having a big innovation day, and they invited me to come. So I'm going to go do that right after we're done. We can't be late today.
Okay, we're not going to be late. We're going to be, we'll be prompt, and everything will be like that. And for those of you that haven't seen this is the kitchen set. It's actually the kitchen of my apartment in Silicon Rainforest up here. The bedroom set wouldn't work today because the sun is shining right through those little, what do you call them? Blinds, the blinds. It's shining right through there. And because all the windows are open here, we may hear a lawnmower man again. So we'll see if that comes by. That seems to always plague me right about now because it's now freshly sunny outside again. Okay, so now I'm just wasting time. Last week, we had a very interesting guy on, Will the Chill Braswell, talking to us about his overall Perl 11 project. We wanted to focus this week down on the specifics of his personal part of the project, which is RPerl, and also a couple of other Perls, MathPerl and PhysicsPerl. We'll have plenty of time to talk about that in a second, but I found out a lot of stuff about how the Perl community is actually working on making things go faster and faster, and with more variety, more support and stuff like that last week. So I'm glad we got to bring him back for a second week so we could talk more about this. Aaron, what do you think about it so far?
Well, I'm glad we get to continue the conversation because we kind of, both you and I said at the end of the episode when we were done, is there was a lot more we could have talked about, as is usually the case on Floss Weekly. And so it's nice we can just kind of keep the conversation going. So yeah, I'm excited to keep going and talk about RPerl.
Very good, very good. Well, before we do that, I have a little bit of business to conduct because this episode of Floss Weekly is brought to you by Braintree. By next year, maybe even next week, there could be a whole new way to pay. Maybe it'll be the next Bitcoin or the next Apple Pay or maybe even both. Fortunately, Braintree's full-stack payment platform is easily adaptable to whatever the future holds, so you can adapt easily too. You can accept everything from pounds to PayPal to that next big innovation from any device with just one integration. And when that new payment method comes out, all you have to do is update a few lines of code. No late nights, no complex recoding, no stress about staying ahead of the curve. Braintree Payments is here to help. It has simple and secure payments, code you can integrate in quickly. The Braintree code supports Android, iOS, and JavaScript clients. There are SDKs in 7 languages: .NET, Node.js, Java, Perl, yay Perl, PHP, Python, and Ruby, and an elegant code with clear documentation. Braintree gives you an easy way to accept multiple payment types with one integration. Integrating it into your app is as easy as inserting a few lines of code. Learn more at braintreepayments.com/floss. And we thank Braintree for their support of this show. So let's go ahead and bring Will the Chill back all the way from last week.
Hey, everybody. Thanks for having me back.
Yes. Well, we covered a bunch of subjects last week, but I told you to kind of stay away from RPerl because I wanted to really focus in on what that's all about. So I'm glad you got to be back. So let's start from the top. What is I mean, first off, anybody who didn't hear last week's show, go back and play that first because we want to dovetail that with this. But what is RPerl? What problem is it solving?
RPerl is a high-performance Perl, and we're specifically focused on getting as much speed as we can, basically. So the problem that we're solving is the slowness that you're going to find when you try and do certain high-performance projects using Perl. So that's kind of the very, very short answer. RPerl exists to solve the problem of needing more speed in Perl.
Is RPerl a subset of Perl, or does it still compile everything like maybe most of the stuff in the CPAN?
Very good question. We had mentioned last week a fork of Perl 5 called CPerl, which is used to have full CPAN compatibility. RPerl is not meant to have CPAN compatibility. It is a restricted subset of Perl 5, which is what the R stands for. So we only support the parts of Perl that can be made to run at the speed of C. So we are going for the jugular, we're going for the gold, and we do actually, because we're already at version 1.7, run at the speed of C.
Well, that's a pretty big claim. I mean, what are you doing? What's the mechanism behind this that lets this happen?
Well, that's also a very good question and a pretty deep technical question. Basically, there has been for many years a way to connect together Perl and C code that's called XS, or external subroutines. And this is kind of like a Perlish assembly code type of in-between language. Perl is often termed a glue language. Well, this would be like a glue language for the glue language, a meta glue language, if you will. And XS is used to basically to enable you to call back and forth between Perl and C. The problem is that it's very technically complicated to write XS code, and it's perhaps more error-prone or buggy or difficult to maintain because of that. And it is a different language, and it is an assembly flavor kind of language, so it's not for the faint of heart. So really the only people that could afford to spend the time to write XS code would be those who had the most burning need to have a connection between Perl and C, which was not always because of performance. It could be because they needed to access some libraries in C that were only available in C, or for any other type of business reasons, perhaps. Lots of different reasons you could need to do that. But basically what we did with RPerl was we, again, hearkening back to previous discussion of Perl 11, the philosophy of Perl 11 started up by Ingi and Rainey and myself. Well, Ingi, a long time ago, had created a software called Inline, and Inline allows you to automate the process of writing XS code. So Inline helps you to not have to write XS code by hand. It makes it much more easy to connect Perl to C. So the way that RPerl works is it has its own grammar, which is a grammar that I wrote. It's a subset of the Perl 5 grammar and can be extended to be a subset of the Perl 6 grammar, and then can be further extended to be not just a subset, but to support the entire grammars of both languages. But right now, we support a subset of the Perl 5 grammar, and that compiles into C code, or really C++ code, just depending on which features you're using. But it's kind of the same thing because they both get fed through the same compiler, which is, in most cases, the GCC compiler, or whatever C compiler you have installed on your system. And and it uses Inline to connect together the end result of compiled C code to link it back into Perl, so that the Perl 5 runtime and the interpreted Perl code never even realizes that it's calling into C code. It just thinks it's calling a normal Perl subroutine, and it just so happens to run several hundred times faster.
Wow. And what are you sacrificing? What's a sample of something that I cannot do in RPerl, but I can do in regular Perl?
So as I mentioned, our first RPerl grammar is a subset. And so we did have, as you said, to sacrifice several things. And what I had done was spent a couple months researching all the parts of Perl 5 that run slow. And I ended up making a somewhat tongue-in-cheek low magic Perl commandments, which you can find right on the rperl.org website. And that lists out in the style of Perl best practices and referencing Perl best practices, the book, a bunch of thou shalt in one column and thou shalt not in the other column. And these are things, to give you examples as you requested, such as don't use magic operators like the rocket ship operator or other things that are kind of hidden features in Perl. Don't use the special character variables like $! Or $hash or some other bizarre things that only a Perl person would know what it means anyway. So what we ended up with is a subset of the Perl 5 language that looks and works as much as I could make it like a pseudocode type language with, of course, $signs, because in Perl we love sigils. So the reason why I like to mention that pseudocode aspect is because that's kind of the easiest thing to understand as a programmer, or even often as a non-programmer. What are you going to write down on a napkin in a restaurant when you're trying to convey an algorithm to your friends? You're probably not going to try and do syntactically perfect code. You're going to write down some kind of pseudocode. So obviously you do have to follow the exact RPerl syntax, but I tried to make it as easy and readable as possible.
Well, one area that I think I'm just hypothesizing here, since I haven't actually looked at any of the RPerl documentation. One area that would be troubling to compile Perl code to C would be the fact that the scalar is overloaded to be both a string or a number. Is that something you had to sacrifice?
That's a very good question. So basically, when you're looking at the internal representation in Perl, because Perl is itself written in C, there's a data structure, a C data structure called SV, and that stands for scalar value. And inside of that scalar value, it's essentially a union or like a struct, a C struct that has possible areas to store string values, numeric values, and other magic values, and so on. And what this allows you to do, as you just mentioned, is to have one variable, like $foo could be the name of a variable, and that could you could initially use it to store a string in that, like hi, my name is Will, and then at a later part in your program you could overwrite it to store a number. And internally, the C representation in that SV internal representation will switch back and forth, and it will have the magic inside to know which value it should be telling you at which point. So the reason I'm explaining that is because in RPerl we have several different modes that you can use to compile your code in, and that's a very deep technical conversation. But to give you an overview that helps you understand the answer to your question, if you consider the normal Perl interpretation, like when you just run normal Perl code through the Perl executable, that would be Perl operations running on Perl data types, and it would be a 1x speed. If you use RPerl, there's two different compile modes that affect this conversation. You would have C operations that are themselves operating on Perl data types, like the SV we just mentioned, and that would go about 7 to 10 times faster, maybe. And that would not sacrifice the question that you just asked, if you could use one variable to store multiple data types. Then we have a third compilation mode, which is my personal favorite and the most important one, perhaps because it's the highest speed, would be C operations on C data types. And in that case, you would want to tell it that it's either a string or a number or something different than that. And we do have specific data types that I could get into if you were interested. But basically, if you do that, you're going to go from 1x to 10x to several hundred x, as I mentioned. We're talking like 200 to 400x, not 200 to 400%. So for me, needing to tell it that this variable is a string versus an integer is worth getting 400x performance.
Yeah, this is actually very germane to some of the things we talk about with makers, because we've got two platforms that makers like to run on. One is Arduino, one's Raspberry Pi. The nice thing about Arduino is it runs much, much faster. So you don't have as much memory to use, but you can do things like control LEDs and make changes very, very, very quickly. Where the Raspberry Pi, you get some latency there, because just because of the way, especially if you're writing in Python and you have to interpret the commands. And I think this all goes back to what you're saying. You're basically cutting out, you're sacrificing a little bit of the shortcuts that people are used to using in order to get that speed. And if that's the case, if I wanted to take a program I wrote, let's say in Perl 5, and then now use RPerl, how much rewriting would I have to do in order to get it into RPerl and see these efficiencies you're talking about?
Very good question, and yes, your observations are correct. The answer to the porting or upgrading question, if you had an existing Perl 5 code, would be moderate amount of work. Basically, you can keep all of your modules and subroutines and drivers pretty much in place. I actually just released version 1.7, codenamed Tycho, which finally includes the ability to compile standalone executables, whereas previously up to 1.6 we only supported compiling .pm Perl module files. So right now our compiling granularity is on a file-by-file basis, which means if you want to have some really super high magic code that you don't want to upgrade, then just move it into a different .pm file and keep all the code that you do want to upgrade in its own PM file, and then you just call the compiler on the one you do want to compile. So all the subroutines can pretty much stay the same. You would the main thing is you would need to add those data types to get the super speed boost. And you would need to cut out any of your little secret shortcuts like $_ or something. Just use a real variable name like a real programmer. Well, I know that Perl 5 people will hate me for saying that, but oh well, I wrote a compiler, you didn't. Ha!
I was just going to say, can I still use $_? Because I use that a lot. I'm not a real programmer. I still use $_. Not with RPerl though. No. That's funny. You know, I haven't done much Perl lately, but I remember using. I was like, oh, $_. That's awesome. So
well, that's a shortcut. That's a commonly used shortcut, and we can add that back in the future grammar. We just had to start somewhere, so we had to cut out as much of the high magic stuff as possible just to get a starting point. It would have been an intractable problem to try and compile all the high magic at the start.
Right. Right. Well, and the other thing I was wondering, it sounds like you've already done this with the compiler a little bit, but is there a way for me could there be some sort of a tool that I could use that may not actually go in and change all my code, but would at least highlight where it wasn't valid, or, hey, this isn't going to work with RPerl, you know, here's a couple lines you need to go take a look at. And maybe give you some suggestions on how to change that so that it would work with RPerl. Because I think that would be really helpful to get people into using this, to say, hey, look, yeah, I've got this program, it's not running fast enough, I'd love to be able to use Perl, but I don't want to go in and change thousands of lines of code or even more, tens of thousands if it's a really long program, to go get it to work with RPerl. Is there any plans for a tool like that, or do you just you know, execute it and see where you get a problem, go through the normal debugging procedures?
So that's kind of a two-stage question, because the first stage you would need to do is to profile your code and find out which part you need to care about compiling anyway. Because there are things that Perl does fine, like regular expressions do not need to be compiled or sped up because they have their own special engine anyway. That's not even just normal Perl 5 code at all. It's a whole different sub-language. Something that's just based on accessing databases doesn't need to be compiled because the database is already written in C, and it's, again, not really relying on the Perl 5 runtime. But if you run a profile such as NYTprof, which was created by the New York Times because they have a ton of Perl code and they wanted to find out where their slow parts were, you can highlight the hot parts of your code or the computational kernels of your code which need to be compiled. Then again, as we mentioned, put those in their own .pm file, and then sort of the second part of this process would be, as you said, sort of highlighting which lines need to be addressed. And we have gone to a significant effort with RPerl to provide a multi-leveled message syntax checking and error messaging system so that it can tell you almost exactly why your code line by line needs to be changed in order to be upgraded. And the way that works, to just give you a brief preview, is the first thing it does, of course, is just send it through a normal Perl interpreter with high level of warnings and strictness turned on. So that's kind of just going to make sure that you're not writing terrible Perl code. And that's just, again, running through the normal Perl interpreter. So that's the first sub-phase of the syntax checking. The second sub-phase of the syntax checking is running through Perl Critic, which is a software that's created by Jeffrey Thalhammer, if I got his name pronounced correctly, in order to implement the ideas that originally came out of the Perl Best Practices book. And plus a bunch of new best practices that kind of came out after the book. And so Perl Critic itself has multiple levels, numeric levels that also have hilarious nicknames such as Brutal. And so Perl Critic level Brutal is the most difficult level to pass on Perl Critic. And surprise, surprise, you have to pass that level as, again, the second phase of syntax checking. And so there's it can give you a line-by-line breakdown of any issues that you have with normal Perl best practices. And then if you pass that one, it finally drops into the RPerl grammar, which I had mentioned a minute ago. And that one has a whole bunch of tips that I put in there for common errors that people would need to address when upgrading their code, to kind of say, please try to do the following. It may help you fix this issue. So we have a pretty robust reporting system for what you're trying to do. I think that you're kind of hinting at even one step further than that, where you could highlight the actual code and say, you know, tell me, what is this variable, a string or an integer? And that would be something that I have not done yet, but that I have actually been thinking about, an interactive IDE that would be based off of the principles I just explained to you, where it runs all of this stuff in the background to do all these checking and then highlights where you need to update the code, and can even tell you what it's doing as far as compiling or interpreting it as you write the code. So that level of interactive IDE and code upgrade assistant does not exist yet. But I'm pretty sure that you just volunteered yourself to do that.
Yeah, I'll carve out just a little bit of time there to get that done. But that's awesome. I mean, this sounds like you've gone really, really far down this path. I mean, what you already have is a lot more than I was expecting. So I'm already really pleased with how far this is along that road of trying to help the developer figure out how to do this. And I already know that none of my old Perl code's going to pass.
Not likely.
It's not likely at all.
Not likely at all.
Yeah.
No.
So let's talk a little bit about what you would use this for. I mean, we talked a little bit about it at the beginning. It's obviously faster, but what application requires this? What couldn't you do with Perl before that you can now do with Perl, with RPerl?
So I think that's a good segue point to mention the RPerl applications or projects that we're doing, which include MathPerl and PhysicsPerl, which harken back to the naming convention of the currently existing BioPerl package. And so BioPerl is a collection of a whole bunch of different Perl interfaces to biology software. And notice how I carefully worded that, because the somewhat dark secret there is that almost none of BioPerl's actual computational code is written in Perl, because if it was, it would run so slow that no scientist in the biology area would be able to use it. So what they've done is simply take a bunch of C code and then wrap it in Perl interfaces by using, for example, the XS or inline type technologies, and there are a few other related ways to do that, combining Perl code and C code together. So BioPerl does exist. It is used widely in the biology industry because it's easier to use Perl than C. So especially for people that are not computer scientists or professional programmers, such as a biologist, they would want to be able to use Perl instead of C. It makes it much easier for them to just kind of jump in and hack together some little quick code they need for a genome sequencing project they may be doing. But again, not written in actual Perl. So MathPerl and PhysicsPerl, which are brand new, both just version 0.1 released on CPAN the last few holidays we've had, those are written in Perl, specifically RPerl, and a bit of regular Perl to kind of handle some of the wrapper stuff and graphics and stuff. But basically, I've just had to, again, get started somewhere. So I chose some math routines that I've been working on with some of my science buddies, and some physics stuff that I've been working on with some of my science buddies. And because I'm a scientist, and the reason why I wrote RPerl in the first place is so that I could have a super fast Perl for scientific computing. And unless you're a mathematician or a physicist, you probably won't be too terribly excited about the stuff that we've released in there. But there are actually a few cool little graphics programs. In PhysicsPerl, you can look at the N-body solar system simulator code, which will actually give you graphics that show the sun and the planets whizzing around and the gravitational computations of all that. In the MathPerl, we actually do have like a graphical program for generating fractals. And there's a bunch of other code in there that's not so enticing for non-scientists, but these are packages that are written for scientists to use. So obviously, we need them to be focused on science. And I will continue personally implementing code through MathPerl and PhysicsPerl using RPerl as we move forward, so that more and more scientists that are in academia or in the corporate world or wherever can access this free and Libra open source software.
Well, I have a little bit of business to conduct. So whether you're developing an app, a website, or working on a server-based project, you need flexible, reliable, and affordable hosting. DigitalOcean offers Droplets, which are virtual private servers that can be customized and deployed easily to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you can think of with full root access. This helps you to get your project off the ground quickly and makes it easy to scale when you find success. DigitalOcean is used by over 600,000 developers, including me. I first found out about DigitalOcean last year's Scale, and I found that they had FreeBSD, and I said, yeah, I like FreeBSD. I could put that in the cloud now. You can deploy and configure your droplets via a streamlined control panel or simple API. You can choose your OS, Ubuntu, CentOS, Debian, Fedora, CoreOS, and yes, FreeBSD. Select from any one of the many pre-configured one-clicks like Drupal, Docker, or Node.js to get up and running quickly, or build the exact infrastructure you need with root access to servers running 100% SSDs, and boy, are they fast. It's state-of-the-art data centers around the world. It's highly scalable to meet the demands of a rapidly growing application or business. You can also use advanced features like floating IPs for high availability, private networking, and automated deployments via API. It's an extremely active community with a large and detailed set of tutorials on all the ways you can use your droplet. Want to configure a LAMP server, set up a virtual desktop or VPN? They have you covered. And it's so easy to get started, you can deploy an SSD cloud server in as little as 55 seconds. So DigitalOcean has incredibly affordable and straightforward pricing. Servers start at only $5 per month. There's also hourly pricing available starting at less than a penny per hour. But we're going to make it so you can get started today and deploy an SSD cloud server for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code FLOSS for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do. That's DigitalOcean.com, and once you sign up, enter the code FLOSS in the billing section to get your $10 credit for free. And we thank DigitalOcean for their support of Floss Weekly. Okay, Aaron, go back again.
Okay, so to follow up on what we were talking about, we said math and science. In fact, there are specific Perl versions now that are using our Perl just for that. So, but what about other applications? I'm thinking if it's good for math, then it might be good for things like real-time analytics, data processing, things like that, and also things that may be running in the cloud, although not maybe online applications in the cloud, because you're going to have a latency problem there to overcome anyway. It probably won't help. But if you want to stand up an infrastructure in the cloud and then run some sort of computational thing on it, it sounds like it might be good for that application as well. So what about that? Real-time data processing and analytics?
Yes, I would say so, because you cannot run faster than what we're getting with RPerl. We are actually outputting directly to C and C++ code, so you can get that level of performance. And we do have servers set up on the cloud that are already running our different versions of RPerl and running tests and different applications on there. So obviously that is a future deployment option as well. And we're going to have some very exciting things coming down the pike related to that, working on some automated deployment products where we could stand up some cloud apps for you, sort of just the click of a button. That's not ready for release yet, but we are working on it. And obviously you have things like real-time 3D graphics, video games, movie rendering of special effects, and other 3D needs where you're going to, again, be able to do this at a speed that you would only be able to get with a true compiler, which is what we are providing here. So I'm also working on the pre-release graphics infrastructure so that we'll have a full 3D rendering engine platform available for any of those uses, whether it be games or professional usage or corporate graphics rendering, any of those sorts of things.
Very cool. Now, would this help me with another problem I have? When I mentioned this, I alluded to this before, where I like to use Raspberry Pi for a lot of reasons, but when you're considering, okay, do I use Arduino Raspberry Pi? One of the things that you come up with is, well, I've got limited memory available in Arduino, but if I put it over the Raspberry Pi, and especially if I'm using something like Python, I sometimes can't get the quickness that I need out of it in order to do some things like I mentioned before, running a very large array of LED lights. It becomes very difficult on the Arduino side because I run out of memory to address all those LEDs, and then it becomes difficult on the Raspberry Pi side because I can't get Python to run fast enough to send the commands, and you end up with lags in the response times from the LEDs. So the question is, could I use something like RPerl to speed up that process? Would that help me in that type of a maker situation?
Very good question, and the answer is, as of version 1.7, yes. Because now we can compile to a standalone exe type file, or a.out, or whatever your operating system may call it. And this would allow you to bypass calling the Perl interpreter completely. You would not need Perl installed on your Arduino or Raspberry Pi or whatever, and you could just load your C code directly on there, whether you compile it with your own special compiler or with a normal C compiler, like GCC, or a special one, even like Clang. Those options would all be available to you because we're producing ISO standardized C and C++ code. So any standards compliant compiler should provide you that ability. Also, your question touching on memory usage, again, the answer to that would be yes, because if you'll remember our part of the previous conversation about the SV scalar value type variables within the Perl core that is itself written in C, the usage of those data types is one of the major contributing factors to having a memory inefficiency, and that's going to be the same similar drawback that any dynamic language would have. Python, Ruby, Perl, any of those kind of guys are going to all fall victim to having wasted memory, essentially. And again, you really cannot beat the memory usage of C and C++. And also, I will give a mention to Fortran, because although I don't use it, it uses the same compiler in the GNU utilities, GCC is used for compiling C, C++, and Fortran. So if I was kind of crazy, I could output Fortran code and use the same compiler, but not really interested in doing that.
Awesome. Hey, when you're talking about processing, numeric data and things like that before, I immediately was reminded by it, and I had to Google it to remember the name of the thing, but MathPerry. MathPerry was trying to accomplish a similar thing. How would you compare RPerl with what MathPerry was doing?
MathPerry, oh yes, I have heard of it. I've not used it, but my main response to either the Perl data language or MathPerry or any of the other sort of Perl plugins or Perl add-ons that are attempting to solve a part of the speed problem, they are providing a specialized solution, and we're providing a general solution. And obviously there's a world of difference. So yeah, that was that. I just made that pun up on the spot. There you go. So yeah, no, I mean, if all you care about is doing one little math thing, then maybe all you need is Piddle. We're going to eventually replace all of that piece by piece using MathPerl. But remember, MathPerl is just one of many different applications of RPerl. So again, RPerl is a general solution. You could write a video game in RPerl just as quick as you could write a little math subroutine. So I'm not in any way against those other guys trying to make their Perl 5 code run faster. I'm in favor of anybody that wants to make their code run faster. I just want to have a general solution. I don't want to be locked in a little box to just a specific solution.
Okay, and actually it was PDL that I was thinking of, but my Googles took me over to MathPerry. But it's a similar thing, a lot of code written in C that then has a nice thin Perl layer over it to be able to do large data calculations and things like that. Let's get back to more general questions, actually. So is this thing in production? Is this production ready? Can I trust my code to it? And presuming it goes through all those phases correctly?
Yes. Right now, if your code will correctly parse through those multiple parse phases that we mentioned, and it outputs the code that compiles using GCC, then at that point, it's just as stable as what GCC can provide for you. There's a laundry list of coming attractions, so to speak, also known as my technical to-do list. There's between 200 to 300 items in the main to-do list and another several hundred items of to-do embedded in the code itself. But overall, this is now out of version 1.7. We've got a test suite, an RPerl specific test suite that's passing over 3,000 tests, and I've got another 1,000 I probably need to write. So it's passing a lot of rigorous testing, all the way down to the most finest grained individual C integer tests and things like that, all the way up to entire programs compiling and running correctly. So for what RPerl currently supports, the answer is yes, you can compile and deploy now for production. And
so what do I have to have? Well, no, I had a different question first. I interrupted myself. Look at that. Inline C, as I remember it or understand it, actually builds the C code and puts it in, I think it's your home directory, or if you install it on the system, puts it in a special directory, and then compiles that down and links that at runtime. Is that, are you using it that way, or is it, or you do something special with inline C?
Very good question again, and a good technical insight. There are, as I mentioned, several modes of compilation for RPerl, and in the first mode that I implemented, which was my most basic attempt at getting something to compile, we just used inline in its most common capacity, which is where you allow it to create a special directory that's called _inline, And inside of that directory, it goes through a hugely complex building process of its own that in the end outputs a .so shared object file, which can then, through other mechanisms, be linked back into your running Perl interpreter. What we've done is to upgrade a bit of inline to how it works. I've got my own code in inline at this point, adding object orientation support, proper support for that, and also kind of deconstructing the way that inline works, where that in the new version 1.7 of RPerl, we now also have added in the ability to have several new compile modes, which include an archive-only mode, which outputs a .a file. For those of you who are compiler programmers or people that know how to do writing C and linking libraries together, you'll recognize an .a file. There's also a mode for outputting a .o file. There's also a mode for outputting a .so file, as I just mentioned, that inline itself often does. And then you can have it output the standalone exe as well. So we've really tried to now expand the way that the RPerl command works, because just like there's a Perl command that you type, Perl space and then the name of your program, same thing, you just type RPerl space and then the name of your program. And so now that RPerl command has all of these new options that give the user control over how the compiling actually occurs.
Okay, and is there a way to kind of pre-bake the .sos when you install it, the same way inline C does?
So one of the mechanisms that inline uses is it can test if it can test to a certain extent if your code has changed, and then recompile if your original code has changed, which can be a double-edged sword. It could trigger false compiles and cost you time, or it could just be a convenience thing and save you time by not having to type the compiler command over and over again. So you can certainly run the RPerl command manually and tell it to output a .so file, and then email that .so file to your buddy, and now he can compile that into his own exe without even needing Perl or RPerl at all on his system, his or her system. So I don't know if that exactly answers your question. I think it was kind of similar.
It sounded close enough. I'm already just maxing out my geek cred here, so maybe I should be a little more careful here. What gets installed? I mean, can I go to the cpan to install this?
Yes. Right now, all you have to do to install is type cpan space RPerl, and that's got a big R and a big P, and then a little ERL. So you can also use cpan-m or any other mechanism to interface with cpan and install things manually if you want as well. You can also go to GitHub and download the tarball or zip file and do it super manually that way. But basically what it does is it does have to install inline, because we know that we already have that as a dependency. You do need to have a C compiler installed. Obviously, that's a dependency. And then, some other smaller things off of cpan. I try to not be dependent on very many other pieces of software, although inline itself is pretty complicated, so that may draw in a number of its own sub-dependencies. But I tried to write as much as I possibly could from scratch so that it's all one ball of code. And so we will also in the future be offering pre-compiled, pre-packaged RPerl installation directly through your operating system, which would be, for example, if you're running a Debian or Ubuntu type system, you could just type apt-get install RPerl. We're not quite there yet, but we are getting close. Same thing if for a Red Hat system or even a Windows or Macintosh system. Speaking of which, we do support most any operating system platforms. I personally only use Ubuntu, so that's what I can provide tech support for. But I know that people have been getting it to work using Strawberry Perl in Windows or normal Perl, I guess, in Macintosh. And then, you've got your BSDs and other type of Linuxes that seem to work just fine.
And you've got a parser in here somewhere. Did you use an existing parsing framework, or did you handcraft all that?
Very good question again. I did use an existing compiler, or in this case, parser. There's, of course, everybody in computer science has heard of YAC, yet another compiler. And so there are a number of other softwares that have come along that lineage, so to speak. The current software for Perl that is most useful and utilized in this case with RPerl is called EYAPP, EYAPP, which stands for Extended Yet Another Parser, which I did not originally write, although I have adopted it now. Its author has gracefully passed that along to me so that I can make sure that it stays updated and bug-free as we move forward. So using the EYAPP framework, you can write a grammar for another language, in this case RPerl, without having to do a lot of the tedious work of figuring out if the Bacchus-Noor form is free of errors and not ambiguous, and to have the lexical analysis mostly automated as well. And all of that can be found in one file, which is arguably the heart of RPerl. And that file's name is grammar.eyp, and you can find that in the GitHub repository. If you're interested in seeing how does RPerl actually work, that is sort of the core part of it there.
Okay, that's a great answer. It's I'm also curious if you've seen MARPA or those other larger frameworks.
I have looked at that briefly. MARPA, there's PEGX, there's a couple other options for parsing. I actually had originally used, way back in the day, before RPerl days, I had used Berkeley Perl YAC, Perl by YAC it was called. So it was actually a port of YAC into Perl by the guys at Berkeley. And that's outdated at this point, so that's why I upgraded to EYAPP. But from what I've been able to implement using EYAPP, there is no need for anything more convoluted or advanced in any way. Everything that we need is directly supported by EYAPP. It is a very robust system, and I'm very proud to be able to carry on that legacy as the new EYAPP maintainer.
Okay, when you brought up Perl best practices earlier, I was actually cringing a little bit. I have a talk that I call Perl second best practices, where I actually disagree with about 100 of the points and explain why. So, so now I'm thinking, oh my God, now my code has to look like Damien wants it to look, and so anyway, I do have a little talk.
Well, my response to that would be, you may have had 100 points that you disagreed with. I've got about 30 or 40, but mine are formalized as part of the RPerl grammar. And so in order to actually pass on certain sub-phases of the parsing, you have to utilize specific no-critic operations in order to disable one piece of Perl critic at a time in order to enable a certain feature that you're trying to do in the compiler.
Okay, and also, does RPerl end up in the pound bang line, or is it a separate tool that generates some sort of chunk of stuff?
Another very good question, and I am just about at the point now where I've actually started stubbing out software with using RPerl in the shebang. So instead of having hashbang user bin Perl, you could put hashbang user bin RPerl, and it would do the same thing but compiled. And we're just on the cusp of being able to deploy that now. I'm starting to experiment with it internally, but the RPerl command is robust enough to be able to handle that in the immediate future.
And also, another place that needs speed ups is ModPerl. Can this work with being loaded by a ModPerl application?
I haven't done it myself yet. Somebody else may have done it, but there should be no reason why we can't do it. And the reason why I say that is because I've very carefully kept RPerl to be backwards compatible with everything in Perl 5 that has been both interpreted and compiled up to this point, by which I mean normal XS code can interoperate with RPerl to a certain degree and whatever you may need it to do. And also interpreted Perl 5 code can call back and forth to RPerl code. And those are kind of the two main categorizations of sort of previously existing Perl 5 code. It's either pure Perl or it's Perl plus XS. So mod Perl is kind of its own beast. And again, I haven't tried to address it directly, but there shouldn't be any technical reason why we can't do that.
So where do people get started? I mean, we talked about this before, that like your grammar, for example. So I've got a program, it's not running fast enough. I want it to get it to run faster. Where's the best place to start to learn the grammar? What am I going to have to change and go through that whole process?
Great questions, you guys. So if you go to rperl.org, there is a link there for Use RPerl, and that can bring you to the pre-release for Learning RPerl, which is our new textbook that is a 0th edition pre-release. So it's not done yet, but I have gone ahead and published the parts that are readable, and we're updating it nearly on a daily basis because that's being currently covered by our second grant from the Perl Foundation. So there are already a huge number of code examples, and what I've done is to hearken back to the masters, one of whom happens to be on this show with us today, and take a page from the book, so to speak. I've gone through the exercises in the book Learning Perl, and I've written them all from scratch in RPerl, which means they are pretty different than what you would see if you were using the original High Magic book with High Magic code. So, for example, for those of you that have already purchased the book and have used Learning Perl in order to learn Perl, then you already know all of these exercises, and it's going to be a throwback to remember when you originally wrote them in High Magic code, and now you can see how they would be written in Low Magic code. Compare the two together, compare your own notes to yourself, and that is our that's our methodology for helping people learn by providing code examples that would already be familiar to them. In addition to that, we're writing an entire textbook from scratch that corresponds to all of the RPerl components and how to utilize them to build those code examples. So I've already got the code examples written up through chapter 6, but only the content written up through chapter 2. So that just gives you an example of where we're at right now on the development of that particular textbook.
I think that's awesome. I think that's a great way for people to learn. That was actually going to be my follow-up question is, are you going to have examples where you show, you know, okay, you write it like this normally, and then here's how you write it in RPerl, and it sounds like that's exactly what you're doing based on an existing publication that not everyone, that a lot of people will be familiar with. So that's fantastic. There's already been a few people in the chat room that have said they're gonna check this out. They're gonna get started on it. I know we're kind of getting in deep into programming. We don't do it a lot here, but I think it's good to do it once in a while. But there was one question Esol had, which is, do you foresee RPerl becoming what everyone codes, you know, just what everyone uses to code with Perl eventually, or is there a reason for Perl and RPerl to coexist for a while?
That is the big question for anyone in the Perl community, and it has a very complicated answer. I will try to break it down because that's the point. There are several mechanisms by which RPerl can be used to achieve the biggest existing goal in the Perl community that transcends both Perl 5 and Perl 6, and that is the reunification of Perl 5 with Perl 6. And we've waited, umpteen years for Perl 6 to be released. We've had Perl 5 for 28 plus years. And so there's a lot of technical investment in these two very different code bases and software projects and languages that are not exactly compatible with one another. So there are a couple different ways that this could kind of pan out. There's a 4-stage progressive optimization technique that we could use, basically combining together the existing low magic RPerl, a new to be created medium magic RPerl grammar, the existing CPerl, which as we mentioned last week is a fork of Perl 5 that runs about twice as fast and provides 99.9% CPAN compatibility, and then normal Pumpkin Perl, which is the existing Perl 5 core. If you combine all 4 of those together, then basically what you would have is a 4-stage parsing where that it could figure out which category your code fell into and then run the fastest one available. And you as a user needn't even know that this is taking place. It could be hidden from you within the Perl core itself. Another relatively different approach would be some of you in the Perl community with long memories and important things that you've thought about in the past may remember there was a project named as Pony, and that stands for Perl on New Internal Engine. This never exactly worked out. It was meant to recode the entire Perl 5 core using the Parrot virtual machine. Parrot never exactly worked out, so Pony never worked out, and they both taught us a lot of lessons, but are not going to ever be used in production. So what we would do is resurrect Pony with a Pony version 2 or Pony Redux or something along those lines, and attempt to completely re-implement the existing Perl 5 core using RPerl instead of what it's currently written in, which is C89, the 1989 standard of the C language. And by doing that, we would end up with a version of Perl 5 that would be much more maintainable and understandable and upgradable and faster, more than likely, or at the least the same speed, but potentially you could incorporate a lot more advanced optimizations in if you had a full rewrite so it could become faster. And then a third option, we kind of mentioned on the previous show that Perl version 11, well, it wasn't actually a version, it's just called Perl 11, and that Perl 11 is a philosophy, and it's an idea of having Perl pluggable on many different levels. Well, there is a Perl version 5, and there is now finally a Perl version 6, and eventually there may be a Perl version 11, not just the philosophy, but an actual version 11. And that would be an even more futuristic, difficult road to go down, but we'll probably need to eventually do it. And that would include rewriting Perl 5 using RPerl, perhaps, and rewriting Perl 6 using RPerl, perhaps, or rewriting some core components of each using RPerl so that they could be combined together, at which point they would, the languages of Perl 5 and 6 would be compatible internally with one another, which is kind of the holy grail that we're all praying and hoping that may happen someday. And I hope it's not going to be 28 more years, and I also hope it's not going to be even another 15 years before that happens. Hint, hint.
Yeah. Yeah. Hey, we're really out of time here. I want to keep going on. We could do another hour on this. I can see this really easily happening. But since we're out of time, I'm just going to say thank you for coming on these past 2 shows and really getting us going. It looked like the chat room was kind of going off the hook here about some of the things this might actually offer. So, and keep up the good work. One quick last question. What kind of people are you most looking for to help you out?
Well, if you can write normal Perl code, then you can write applications in RPerl now. And if you can write C or C++, then you can help with the RPerl internals. I would invite you to come onto irc.perl.org, channel Perl 11, or just rperl.org, or even on Facebook, I will respond personally. And remember, RPerl is faster than your Perl.
That's a great note to end on. Thank you, Will Chill, for coming on and talking to us about your favorite projects. Bye. Yep, there we go. What do you think, Aaron?
That's really exciting. I mean, I'm anxious to try this actually on a Raspberry Pi and see if it helps speed up some of the processes that we're trying to do for some of the things I just mentioned. There's still some other layers to it, obviously, with interrupts and other things going on in the system. And, do we need to run a real-time OS and all that kind of stuff? But, I'm not looking forward to trying to write assembler on Raspberry Pi to try to get some of those speed improvements. And I already know Perl somewhat. So I'd rather use Perl if it comes to that. And so, maybe this is a way to get that done. I think also that this brings... I mean, Perl already has, for those that don't know it, a rich community built around it, right? But I think this already brings out yet another avenue where someone who maybe had passed Perl by may want to take a second look and come back and say, hey, this is actually something I could really use because I'm having some problems here or there with speed. This is something that actually would be really useful. So I know we got in the weeds today a little bit, but for me, it was very interesting. I don't have to ask you if you thought it was interesting. So for those guests that maybe aren't programmers or don't know, I mean, it's still actually very valuable. I was thinking during the show, the song Rapper's Delight. This is like Programmer's Delight these past couple of episodes where we just kind of go deep in the weeds on Perl. But yeah, really exciting stuff.
It was, definitely. And I'm pretty sure I will be playing with this, although I say that about almost every show, but this one is really apropos for me, so I'm definitely going to go check that out. And I know you got to get out of here, so I'll go ahead and start doing the wrap-up here. So for the upcoming guests, we have a surprise guest next week. That's because there's still a question mark in the first column on the schedule. I just remembered that. I have 4 or 5 people looking at dates, and I just need to nudge them in a couple days here to get that filled in. And then following that, we're going to be live from OSCON, and that means I have to find a guest within the first day that I'm there, coming from Austin, Texas. And then we have Buoy, which is a private community-based crisis response system, so that you can let your friends know that you're possibly in a dangerous place, and they'll send your GPS coordinates to your friends and things like that. Simplay, which is a simple API for making PDFs out of templates. We also have the best practices badge, which means that you go through a questionnaire, see if you're following best practices. If not, you can change things. But once you get the questionnaire all answered yes, then you can have a little badge to stick on your website and in your documentation to say, I do follow best practices, and here's how you can too. Really, really wonderful program. We're still filling up the schedule. Twit.tv/floss is the homepage for this show. You find a link there to the big spreadsheet of how I'm trying to get everything done. Always could use more guests. Please have the project leader or community director email me. My address is on that page, merlin@stonehenge.com. We do have a live stream. We took a couple questions from it this time, usually 9:30 a.m. Pacific time on Tuesdays. You can follow us at Floss Weekly on Google Plus and at Floss Weekly on Twitter. You can follow me at Merlin on Twitter, and Randall L. Schwartz on Google Plus is where I do most of my original material, except when I'm playing with my Facebook friends. Like I said, I'm going to be at OSCON in a couple weeks. We also have YAPC North America, where I'm going to be talking about Perl. Maybe there'll be some RPerl conversation. That'll be kind of cool. Fizzle, I'm doing that's the big conference in Porto Alegre, Brazil. I've been invited to be one of their featured speakers. So I still got to write up what my topic's going to be. And then in September, Dragon Con. So I'll be on the EFF track there, probably doing something related to the Mozilla encryption thing. So I want to actually do a whole program on that. Quickly, co-host plugs. I guess that's you, Aaron. Yep. Anything you want to plug? Right.
Yeah, I'll try to get these as quickly as I can in chronological order. So coming up this Saturday, I'll be on the new Screensavers here in studio. So I think we're going to be talking about some cool projects that I'm going to bring with me. So tune in for that. And then next week, I'm at IOUG in Las Vegas. So if you're a DBA or an application administrator and you want to come say hi, I'd be glad to say hi, give you a free book. we're giving out these little books as a free giveaway. I'll give you one of those and just talk. Maybe we can get a beer or something like that. And then on April 16th, if you're in the Bay Area, make sure you check out Benicia Mini Maker Faire. We're putting the final touches on our laser maze, which is new this year. Not something you see at other maker fairs because they're kind of hard to do as we're learning right now. But fingers crossed, we'll have it ready for April 16th. So come check us out and get a 20% discount when you use the promo code TWIT when you buy your tickets at BeniciaMakerFair.com. That's it.
Awesome, awesome. Okay, well, Aaron, thanks for joining me. Well, I guess it's us counting the guests.
Yeah, sure.
Yeah, right.
And John, don't forget John.
Yeah, John. Well, he's back in the back seat, sir. All right. Anyway, and I guess we'll see you all again next week on Floss Weekly.